Why is the image on the left so bad? Digital images are made of little squares of color. This is a smiley face made of 16 squares. This is a cute little squirrel made of 600. And this is Tokyo made of 9 million little squares. Each square is exactly one and only one color, and it's called a pixel picture element. When people talk about image resolution, they're basically talking about one of three rough categories. One way to talk about it is the way your mom talks about it, which is give me a generally high resolution image. The second way is the photographer's definition, which is very precise, it's very exact. What are the pixel dimensions? What's the resolution? And the third is the extremely technical engineer's definition, which actually has a formula attached to it. It's what is the smallest physical real world particle that you can possibly make out in this image. When your mom says, wow, this is such high resolution, what does that actually mean? Well, it means that currently you can't see the individual pixels. What do I mean by currently? Well, where are you standing? If you go out to the highway and put your face directly in front of a billboard, you're gonna see the little squares of color, because the billboard makers know that you're gonna be sitting 100 yards away in your car driving very quickly, so they're gonna make the resolution just high enough to where the image looks perfect from your Honda Accord. Image resolution is subjective and it depends on context. Instagram caps your profile thumbnail picture at like 150 pixels wide, which is totally small, but it's fine. It's actually perfect for Instagram because you're only ever gonna look at it this big on your phone. Professional photographers understand the mechanics of pixels in a way that your mom doesn't. Professional photographers want to know how many pixels are in every row of this picture, how many pixels are in every column, what's the shape of the pixels, are they square, are they rectangular, what's the length in micrometers of each pixel. Can the pixels be any color, or can they only be certain shades of gray? How bright can they be? How many different shades of color can they be? Did we make these pixels by adding paint to a white page, or did we make them by adding light to a dark screen? Professional photographers also understand the difference between analog and digital photography, but for right now we're gonna be talking just about digital, so we have to understand the digital image pipeline. So here's how it works. You have a real world thing, like a squirrel, with extremely high resolution, because remember, it's made of atoms. It's way more resolution than you could ever even see with your own naked eye. And then you have a digital camera. A digital camera is a machine that looks at a tiny, tiny little patch of the squirrel, and it averages all the colors in that little patch into one color, stamps it in as a pixel, and records the location and size and color of that pixel as little numbers on your SD card. So this SD card is full of millions of numbers for every picture. So the next step is to take the SD card, put it in your computer, and upload those numbers into something like Photoshop, which will read every single number and print the pixel size, location, and color onto your screen, which creates a digital version of that physical squirrel. So first it was atoms on a squirrel, and then it was numbers on your SD card, and now it's little squares of color on your computer screen. If you're just posting the picture online or sending it to a friend, then that's the end of the pipeline. But a lot of times you're gonna want to print it onto some physical object, like a piece of paper. And in that case, you have a whole new host of things to think about. Great photographers understand every step of the image pipeline, and they know how to optimize their image every step of the way. But here's the thing, a picture doesn't actually have to start with a physical squirrel made of atoms. You could start in Numberland. You could start by saying, I'll tell you a mathematical formula for exactly every line of this image, and then from there, you can use that math to create an image. If you do this, you're not using pixels at all. You're just using mathematical formulas, and images like this are called vector images. If you use pixels, they're called raster images. So when someone says vectorize, they mean convert pixels into mathematical formulas. When someone says rasterize, they mean convert vectors into pixels. Vectors are great because you can scale it up to any size. You can have a vector smiley face that's a 0.5 millimeter long, scale up the lines and curves and suddenly it's 100 feet long. Now, you can't just print vectors. You can't even look at vectors on your screen. It's just numbers. So what you have to do is rasterize it, convert it into pixels. Once you do that, you can print it on a billboard and it'll look great. So Adobe Photoshop, the engine of that software is designed to work with pixels. Adobe Illustrator is designed to work with vectors. But I just said that you can't print vectors. Yeah, that's true. When you're looking at Adobe Illustrator, you're looking at a continuously rasterized version of a bunch of mathematical formulas. But vectors have downsides because you can't really do anything photorealistic with it. It's extremely complicated. You can try, but if you try to do a face with it, it's gonna be really creepy, uncanny valley, kind of weird. Engineers count image resolution in terms of distance. What's the shortest distance between 2 points where you can still make out the difference between the details of those 2 points? If you have a petri dish with bacteria in it and you try to take a picture of that bacteria with your iPhone, you can't see the bacteria. Why? Well, what if you zoom in on that picture as far as you possibly can? Zoom, 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 zoom. Suddenly 1 pixel is as big as the whole screen. You're not gonna see that bacteria. But it's there. The bacteria is in that pixel. It's physically there. It's not that it disappeared. The problem is that a pixel averages all the colors and all the light in that one little area of physical space into one single color. It destroys the detail. It destroys the information. Engineers want information. That's why they use microscopes. That's why they use telescopes. And resolution is how much information are you gleaning from this image? When your mom wants a prom picture that's high resolution, what does she really want? She wants more information. She wants to be able to see the individual details of your nose and the tree in the background. It's the same thing an engineer wants. She wants to be able to see the details of a bacteria cell in a petri dish. Now, so here's some questions. What is the largest, highest resolution picture anyone's ever taken, maybe with a satellite? What's the smallest thing we've ever taken a picture of? Can you take pictures of things smaller than atoms? How do you even know that things smaller than atoms exist? Are there things smaller than the things that are smaller than atoms? These are the questions now that nobody alive has the answer to yet. You should go and try to figure it out.